Similar kind of question in graded. Like I'm not asking you to solve it for any one of us or for me personally. I'm just asking if there is a graph of something like that. So how can we just uh like say that
Hmm.
that if the option is correct, I mean, if there is a like f of x is equals to log something, so how
Hmm.
can we say that the graph could be that equation's graph or something? That's why I did ask that actually.
No, so the thing is, it's pretty easy to tell which of the following may not be a graph of the function, but drawing the exact graph is slightly difficult. So the first thing is, okay, so my screen is visible, right?
Yes, sir, it is visible.
So the thing is, okay, suppose you have something like this, let's say log, this log base 10, and suppose you have, let's say x square minus 4x plus 8. Okay, like let me take some example which uh, let's say x minus 2 and x minus 3. So if I multiply, then what I should get, this is basically 5x
5x plus 6.
6, right? Suppose you have this. Okay, so the first thing you have to know that what is the domain of this function, right?
Yeah.
But so you know that this parabola is certainly it's positive, right? It's
Yeah,
the domain of the parabola is say this quadratic function, whatever.
quadratic function.
Yeah. So this domain of this function is certainly R, right?
Yes.
But if you take like if you compose this function with log, suppose you are composing log with f of x. Okay, so this is precisely this function, right? This is
Yes, sir.
precisely log composition with f.
Complete with yeah, with f of x. Yeah.
Correct. But certainly the domain of this function can't be R, right?
It can't be R.
Because
Yeah.
yeah, because you need to know for what values of x, right? This x square minus 5x plus 6 is positive, right?
Yes, sir.
So now the thing is, suppose you draw the graph of this parabola, right? Suppose you draw the graph of this parabola. Right. So what you want, so to find the domain of this function, right? To
Yes, sir.
find the domain of the function, you need to find all the points for which this parabola is.
Uh, I mean, the value is positive.
Yeah, that means basically this quadratic equation is positive, right? So
Yes, sir.
domain of this function, domain of log compose f is basically you need to find all the points in your real line R such that x square minus 5x plus 6 is positive,
Yeah,
right?
it's greater than 0. Yes, sir.
Yeah, because if x square minus 5x plus 6 is less than equal to 0, then log of that thing is not defined, right?
Yeah, it's undefined. Yeah.
Yeah. So basically you need to find the points for which this whatever this parabola is basically positive. Okay. So for that, what you need to do, you need to first draw the graph, right? So if you
Yes,
draw
sir.
the graph, then basically if you see this is basically 2, right? One root is 2 and another root is
3.
3, right?
Yeah.
So now if I draw this graph, then it should look like this, right? So it will come here, then it will cross, and again it will
And
go.
again, yeah,
Yeah.
like that.
So as you can see, certainly this part, in this part, right, in between 2 to 3,
Mhm.
in between 2 to 3, this parabola is certainly it's negative, right? Less than
Yes,
or
sir.
equal to 0, right?
Yeah.
If I if if my x is in between 2 to 3, then f of x, that parabola, is basically less than or
Less
equal
than
to
equals
0.
to 0. Yes,
So
sir.
that means this x can't be inside the domain of the function. right? Domain
Yes,
of
sir.
this function.
Yeah.
Right. So the domain, so the domain is basically for which this parabola is positive, right? So as you can see,
Yes,
this
sir.
parabola is positive in this region, right?
Yes, sir.
And as well as in this region.
Yeah.
So the domain of this function is basically what? Minus infinity
Minus infinity to 2,
to
union 3 to infinity.
union, union 3 to
Infinity.
infinity. So now actually the main problem is, so so basically your first question, like how I can draw the graph of this function, right? Log
Yes.
composition of.
Yes, sir.
So that is now, I guess you can now see the problem. Like, so the thing is, you don't know how this is growing, right?
Yes, sir.
So until unless you have lot of more information, until unless you can't actually draw the graph. Okay.
Okay.
So certainly you can, like, probably you can say that, okay, so if you have this, suppose I want to study, like, not the proper graph. Let's say I want to study some kind of asymptote. Okay, let's say log of f of x. Okay. So one thing I know, that this log of this function is basically not defined in this region, right?
Yes, sir.
Yeah, not defined in this region, right? So this is 2 comma 3. Okay. So most likely it will, so most likely you will have two asymptote here. Okay, so if you see, because the graph log will start from 2 towards minus infinity, right? And
Yes,
also
sir.
it will start from 3 towards
To infinity.
plus infinity, right?
Yeah,
So
yeah, yeah.
so certainly, so more or less I can say that, okay, let's say log, what is log 0 here? Sorry, this is 6. Okay, so yeah, so 6 means it is certainly positive. So okay, so vaguely it will something look like this. Okay, so the graph will look like this. Okay, so again I'm saying, like, since I don't know the exact value, it's pretty difficult for me to draw the graph. Okay, so
It's a rough diagram you're drawing, right, sir?
yeah.
Okay.
So again, I can't guarantee you about this particular shape. Okay, okay, it's
No, no,
because I
still, sir. It's actually giving a rough idea, so it's totally fine.
so because since I don't have much idea about the growth, so particularly to draw a better graph, you have to actually take lot of points. Okay, so you need to take lot of points, and you need to find the values of this function at those points, and using those points you can draw some smooth graph. So if you do that, then certainly you will get a better graph. Okay,
Okay, okay,
certainly you will get a better graph. Okay. So in some sense, this is a really bad way of drawing this function. Okay, so I'll suggest, like, you try to take bunch of points, right? You try to find the values of this log uh, log compose f of 4. Okay, then you try to find log compose 5, 6, then you will get bunch of points, right? You will get bunch of points, and try to draw some smooth curve joining all these points. Okay. So in that case,
okay, sir.
definitely you will get a better graph than whatever I draw.
Okay. Got it. Got it.
Any other questions? Have you guys started solving, like, started week 6, or you are still with week 5?
Yes, started solving.
Yeah, so Are you facing any problem?
Yeah, week 6, yeah, I just started, sir. I'm in the middle, but it seems like it's a quick jump, the week 6. It's until week 5, it was easy to grasp. Week 6 is too much.
Okay, so the thing is, let me tell you, like week six is not, so the concepts are not difficult, but I feel the questions are slightly difficult. Okay, uh, so, so yeah, so if even you are facing problem in solving question, then you should come and ask all those questions. Okay, so definitely we can solve most of them.
Okay, one issue what I found is that questions are not correctly ordered. For example, if I normally I watch one video, then I attend the next assignment.
Mhm.
Then, but the thing is that if I look for, if I try to solve A 6.1,
Mhm.
some of the concepts are not covered in the previous video. It is actually covering in the next video.
Like, can you tell me, like, in that case, certainly we can rearrange the question. If you are facing, if you have anything particular on your mind and which you
Yeah,
can tell.
I'm just in the halfway. Okay, for example, in AQ 6.1, there is something called the ln, natural logarithm is mentioned in the question number 5, but that
Mhm.
lecture is covered in the, I think it's 6.3, I think 6.3 or 6.2.
Oh yeah, the base change thing, right? You're talking about the base
Yeah,
change thing, the question
yeah.
5, right?
Yeah, question 5,
Oh
yeah.
yeah. I had the
It
I
is
had
already
I had the
covered.
In
same
in
issue.
question in 6.1, there is no question related to base change, right?
6.1, the fifth
The
question.
fifth question, sir.
So fifth question, it has nothing to do with base change, right?
No, the options are 0, comma ln 27. At that point, I don't know what is ln means.
Okay,
So
okay,
then
I got it. So
uh,
instead of that,
uh,
basically, okay, so instead of that, what we can write log base C. Okay, so certainly that will make sense, right? So if I ln, if I write it as log base C, then it is fine, right?
yeah, even even log base e also covered later.
No, certainly in the first question, in the first
Uh,
uh, lecture, if you see, like it's more or less about arbitrary base, right?
okay, okay.
So in that case,
Can
I
you
guess no
solve this
problem.
question?
Sorry,
Can you solve this question?
which one?
Question number 5.
So like, can you tell me what is your doubt? Like, have you tried what you have tried?
Yeah, I had tried, but I can't find the domain. Actually, I'm
That is
very
what I'm asking. Like, what you have tried so that certainly I will solve the question. Okay, don't worry. But I just want to know what you have tried and where you went wrong.
actually I'm not understanding what here x e to the raised to the power 3x.
Okay,
I'm not
so
getting it.
just give me a minute. So actually, in the last term, okay, so in a session, actually, I have solved almost all the activity questions of 6.1. Okay, so if you see the last, okay, certainly I'll solve this question, but let me tell you, in the last term session, so in week 6. I have solved almost all the activity questions of 6.1. So probably if you watch, then you'll get a fair idea how actually we can compute the domain of this kind of function.
Okay, okay.
Okay, so let me solve this one. Okay. So so this is your function, right? So the log of, right? This is the function, right?
Yes, sir.
Yeah. Yes. So you want to find the domain of this function, right?
Yes, sir.
So for that, what you need to find? To find the domain of this function, what you need to find? Hello.
Yes, sir, I can't. I don't know, sir.
Okay,
First,
so
we need to understand what is just log x, what is the domain. Then, if it is minus x, what is the domain? Then we need to come back to each formula like that. I'm not sure, sir.
so
Sir, I have
okay.
a thought.
Hmm.
Can I can I share it?
Yes, please.
Sir, inside log, it is minus then the term. So a log function cannot be negative. I mean, the input cannot be negative. So the inside term that we have, x e to the
Hmm.
power 3x minus 27x, that has to be less than 0. So it gets
So if
multiplied with that
yeah,
minus, so it gives us the positive value. So that's what my approach was.
yeah. So basically, this can be minus of minus 2, right?
Yes, sir.
Then it makes sense, right?
Yeah,
Yeah.
absolutely.
So okay. So the thing is, what is first? You have to understand what is log. Okay. Log of x. Okay. So so the log is, so let's say this is a base. Okay. So obviously I have to start with some base, because otherwise this has no meaning. So in generally when I'm writing like this, then this is more or less log uh, 10. Okay. So so suppose you have something called log x base c. So this is basically, it's a so by definition, what is this? This is basically the inverse. Okay. So this is the inverse of this function, right? A power x, correct or not?
Yes, sir.
Yeah. So first, for that you have to understand what is this exponential function. Okay. So this is a function from R to R, right? X goes to a power x, correct? So again, there is some condition on a, right? A can't be less than 0 and a can't be 1, right? So so as you can see, so when if you consider this case, then as you can see, a basically it's greater than 0. So let's say this is 0, and certainly it can't be 1, right? It can't be 1. So basically a is in this interval and a is in this interval. So if a is less than 1, right? If a is less than 1, right? Suppose a is less than 1. So if a is less than 1, if I increase the value of x, then what will be the value of a power x? For example, what is, so half, let's say a equal to half, right? So suppose half power 1, this is half, right? If I take half power 2, this is 1 by 4. If I take half power 3, this is 1 by 8. So if you increase the value of a, then the value of ax will decrease, right? The value of a will decrease. So if you draw the graph, if you draw the graph of this function, then it will look like this, right? It will look like this, because if I increase the value of x, if I increase the value of x, then the value of ax is basically decreasing. Okay. And from the graph, if you see the codomain of this function, the codomain of this function, is basically what? 0 to infinity, right? The codomain of this function is 0 to infinity, right? So now what actually we are now next, let's go to log function. So by definition, what log is basically inverse of a power x, right? This is a inverse of this function, right? So then by definition, log, let's say base a, okay, it's basically it's a function from 0 comma infinity to r, right? Because if log a is inverse of this exponential function, then log a should be a map from the codomain of this function to the domain of this, sorry, the range of this function to the domain of this function. And from the graph, it's clear that the domain of this function is 0 comma infinity, right? So the domain of this log x is nothing but, so the domain of this is nothing but 0 comma infinity. Is it clear why this domain of this function is 0 comma infinity?
Yes, sir.
Yes, sir.
Yeah. So now the domain of this function, log function, is 0 comma infinity, and our next thing is we want to study the domain of some slightly complicated function. Just a minute, let me add one page. Okay, so we want to study domain of this function. Right? So I know that log of x is defined, if and only if x is greater than 0, right? So if you see for this function, what is x here? So in this function, what is this? So in place of x, what is there? In place of this x. So here we have x. So in place of x, what is there for this function?
Minus of x e power 3x.
Correct. So instead of x, I have this thing, right? So to tell that, to find out the domain of this function, I need to find all the points for which this thing is greater than 0, right? This thing is greater than 0. Okay. If this is greater than 0, then log of this is defined, right? Because by definition, log of x is defined when x is greater than 0. So when I have log of something, doesn't matter what this thing is. So this is defined if and only the star is greater than 0, right? So in this case, my star is this one, minus of x times e power 3x minus 27x. Okay. So to find the domain of this function, I need to find all such x for which this condition holds. Okay. So my next task is I need to find all the points for which this condition holds. So now I have a minus sign here, right? If I multiply this minus sign in both sides, then what I will get?
Sir, the inequality sign will get reversed first,
Correct.
and then
Yeah.
we are gonna get the positive of as well
Yeah.
as.
So then, if this thing is greater than 0, and if I multiply minus 1 both sides, then what I will get? E times 3 power x minus 27x is less than 0, right?
Yes, sir.
So now I can take x common, right? So this
Yes,
is
sir.
x times e power 3x minus 27, which is greater than 0, right? So now I have two things here, right? I have two things here. One is, so if you see this this thing, then basically, as you can see, basically I have two things and I have multiplied these two things. One is x and another one is e power 3x minus 27. So suppose you have two numbers suppose you have two numbers a and b, right? When you can say that a times b is less than 0, when you can say that a times b is less than 0.
Either both are less than 0 or both are greater than 0.
Both are both are less
They're of
than 0.
opposite signs.
If they both are less than 0, that means the
The product
product
will
is
be positive.
positive. Either
No,
has
no,
to be
no.
negative, either
Yeah,
A or
so
B at the same time.
so the thing is, they both of them should have opposite sign, right?
Yes, sir.
So you have two cases, right? You have basically two cases. One case is when a is greater than 0 and b is less than 0, right? And another case is when a is less than 0 and b is greater than 0, correct? So in this case, so in these two cases, this one is possible. Okay. If I take a to be positive and b to be positive, then certainly this is not possible. And if
Yes,
I
sir.
take a to be negative and b to be negative, then certainly this is not possible. Okay. So now same thing. So instead of a, I have some x, and instead of b, I have some x, e power 3x minus 27, right? So now then the next thing is when this can be negative. Okay, so again I will get two different cases. Okay, so again I will get two different cases. The first case is when x is greater than 0, right? And okay, and e power 3x minus 27 is less than 0, right? And what will be the next case?
X less than
Sir,
0
X
and
less than
e
0
power 3x minus
and
27 greater than
is
0.
greater than 0.
Minus 27 is greater than 0, right? So now if you see, I want such x for which both the condition should hold, right? I want to find all such x for which both the condition should hold, because I want a to be positive as well as b to be negative. I want both the conditions should satisfy. So I want to find all such x for which both the condition should hold. So from this one, from x is greater than 0, the range is basically what? 0 to infinity, right?
Yes, sir.
And from here, what I want, e to the power 3x minus 27 is less than 0, right? That means e power 3x should be less than 27, right? Correct or no?
Yes, sir.
So then if I take log base e, okay, if I take log base e, it's basically log e 27, right? And what is this thing? Can you tell me what is this
3
thing?
cubes, sir.
3 times x.
It's,
It's basically 3 times x, right?
yeah, yeah.
So this
Exactly.
means 3 times x should be less than log 27, right? So now x should be less than 1 by 3 log e power 27. And can you tell me what will be the value of this thing? Can I
ln3, sir. ln3.
Correct. Log,
LN3, yes, sir.
correct. Log e base 3. Okay. Right? So I want all such x for which this condition as well as this condition hold, right? So from here, what I can get, okay, if you have question, just simply ask it, okay? You don't have to raise your hand. So if x is less than this thing, then I will get this interval, right? But I want all such x for which this holds as well as this holds, okay? And sorry, this holds as well as this holds, right? I want to find all such x for which this thing holds as well as this thing holds, okay? So this thing holds in this region, right? And this uh, inequality holds in this region, right? So I need to find a region for which both the inequality holds all together. Okay, so can you tell me what will be that region?
ln3 to infinity.
ln3 to infinity. So though
0
basically
to
I have
ln3.
0 to ln3.
0 to
basically
ln3, sir.
LN3.
correct. So basically I have to take the intersection of these two regions, right? So the intersection of these two regions. So one region, as you can see, it's basically one region is basically 0 to uh, 0 to infinity, right? Let's say this is infinity, okay. And another region is basically ln log e base 3 to minus infinity, okay. And as you can see, this is the common region, right? This is the common region. This region is basically common to both these two regions, okay. So then from here the common region is basically what? 0 to, right? So in this region these two condition will hold. So this part is clear. Any doubt from this part?
No, sir. No, sir.
Fine.
No, sir.
Okay, so let me, so again from this comparison we have two cases. One is this case. So in this case this equality will hold, and as well as in this case also this equality will hold, okay. So we are done with this case. Let's go to this one, okay. So uh, from this region, from this, sorry, from not region, from this inequality, what we can get, what will be the region for this inequality?
Minus infinity to 0.
Correct. Minus infinity to 0, and 0 is open interval, right? And what now help me to solve this part? What we can get from this region?
ln3 to infinity.
E power.
Yes, sir.
Okay, so certainly don't jump into the answer. Okay, I help means try to solve step by step. So that means if I take log base e power 3x should be greater than log base 27, right? So this is more or less 3x, which is greater than log e 27. So now the same process I can get x is greater than log E 3, right? Correct or not?
Yes, sir.
So then what is this region? What is this region then from this thing? What for which region this condition hold?
So
ln
ln3 to
it's
infinity.
ln3 to infinity. I mean, for the right side.
Yeah, to infinity. So this condition, let me repeat this again. This condition holds in this region, right? And this condition holds in this region. And the thing is, I want a region in which both the condition holds, right? I want a region in which both the condition holds. Is there any so what will be that region?
No
So for
region. There won't be any region.
yeah,
So
because there is
there
no
is no
common
intersection.
no common points in between this region and this region. Okay. So that means this will never happen. This will never happen. So we have to only consider this case. And from this case, our region is 0 comma log E 0 comma log 3 base C. So basically in this region, this is positive. Okay, in this region, this thing is positive, right? That means the log of this thing is only defined on this region. Clear now? Any doubt?
No, sir.
No,
No,
sir.
sir.
Okay. Okay, so do you want me to solve any question related to this same concept?
Yes, sir. One more question.
Yeah, okay. So suggest me some question.
So 6.2 question number 3. I'm just finding that I'm telling you.
6.2
Yeah.
question number 3. Is it related to the same question? I'll come to that. I'll 6.2 question number 3, right?
Or maybe sir number 2 as well. Now number 2 actually includes the domain thing as well. That
Yeah.
also. That would
So
be-
let me solve one question from 6.1. Okay.
okay.
Then I'll jump to 6.2.
Okay. Okay.
So let me pick 6.1 question number 3. Okay. So again, let me tell you, I solved question number 5. Okay. Then I'm going to solve question number 3. Okay. So your task after that, you should go and try question number 4. Okay. So let me tell you, question number 4 is slightly difficult than question number 3 and question number 5. Okay, so you try to solve question number, once I solved, so I already solved question number 5. Now I'll solve question number 3. After that, you try to solve question number 4, and you try it on your own. And if you are facing any problem, then I'll suggest you go back and check the previous year this recording of the previous year session. Actually, in that session, I have actually solved all the questions. Okay. Okay, so let me pick this question. So this is question number 3. Uh, so can one of you tell me what is the question actually?
Sir, f of x is equals to log base 10 of
Just a minute. F of x is equal to
log base 10
bracket
log base 10x whole square.
this square, right?
Yeah, whole square
Hmm.
minus 8 log base 10x plus 15. Sir, 15, sir.
Oh, God, sorry. Yeah. Okay. So again, the same process. Okay, so you have to start with the same process. So here, as I said, whatever it is, log of this log of this star is defined if and only if this star is positive, right? So again, for to find the values for which this star is greater than 0, that may require some different method, but the first process is same for all the questions. Okay, so you need to find the values of x. So as I said, this is my star, right? This thing is my star, right? So this is defined if and only if my star is positive. My star is positive. So what is my star here? Star is what? Log 10x square minus 8 log 10x plus 50, which is greater than, this is if and only if this is defined if and only if this star is greater than 0. So to find the domain of this function, what I need to find? I need to find all the values of x, okay, for which my star is greater than 0, right? So I need to find all the values of x for which my star is greater than 0. Okay, so let me take, so this is my star. So I need to find the values of x for which this is greater than 0. Okay. So this whatever I have written here, this looks like a quadratic function, right? Kind of. Certainly this is not quadratic, but you have a similar kind of expression, right? Hello.
Yes, sir. Yes, sir.
So what I'll do now, instead of writing this log x base 10, I'll simply denote this log base 10. Let's say this is m. So instead of repeating the same thing again and again, I'll just denote this as, right? So this is my n. I'll simply denote this as n. So then this thing, I can write it as m square minus 8m plus 15 is greater than 0, right? So when this is greater than 0, this m square minus 8m plus 15 is greater than 0. When? So, okay. So can you tell me? I basically initially I actually I solved a similar questions like log of x square minus 5x plus 6. So you have something like this now, m square minus 8m plus 15. So when this is greater than 0?
So when the values of the root, I mean, when it's above the root value.
Yeah, so that is certainly correct, but okay, I want the, so that is again, that is sort of vague answer. I want a precise answer, like what is that region?
Oh,
X minus 3 is
yeah,
negative.
from 5 to
X
3.
Again, like if you see, like, so I can factorize this, right? I can factorize this polynomial, right?
m minus 3 m plus m minus 5
M minus 3
Yes.
times
minus
M
5.
minus 5.
m minus 5. So now can you tell me the region?
Minus infinity to 3,
Minus infinity
union
to
5 to infinity.
3,
Minus infinity to
3 and 3 to
Union
5 to
5 to
infinity.
infinity.
And 5 to infinity.
5 to infinity, right? Correct or no?
Yes.
Yes.
Yeah. So that means this is, so in other words, instead of writing this, in other words, this is positive if m is what? If m is less than 3
Less than 3.
Or
Less-
greater than 5.
or
Greater than
m
5.
is greater than 5, right? In this region, whatever I have written here, this expression is positive. And why I want to find? Because I want to find the domain of my function. Okay. So what is m? Now let's go back to m. What is m? What is n? Because ultimately I want to find the values of x for which this thing is positive. This thing is positive. So ultimately we need to find the values of x. Now we got the values for m, but we need to find the values of x. So what is m? So now I'll replace this m as log x less than 3 or log 10 x is greater than 5, right? Clear now? This part is clear?
Yes, sir.
Yeah. So now can you tell me what will be the range for x?
Yes, sir. 0
Yeah.
to 10 to the power
No.
3.
Just
3.
tell me the sorry, sir. Just tell me the next step from here. What I can get next?
We can convert it into
So the exponential
exponential
form we can
function.
go there, right?
Yeah.
Yes,
Yeah.
sir.
So that is what I wanted to know. Yeah. So from here I can, if I take 10 power of 10 in both the sides, then what I will get?
10 to the
10.
power 5 is equals to x and 10 to the power
Yeah.
3 is equals
Let
to
me write it. So this is basically 10 power 3, right? Or 10 of 10x, which is greater than 10 to the power 5. And I know this is nothing but this is x, right? This thing, whatever I have written here, this is nothing but x. So that means x is less than 10 power 3 or x is greater than 10 power 5, right? So now from here, what I can get, x is basically in between minus infinity to 10 power 3 or x is in between. Hello?
Uh, in previous third step means 3 steps before it. If you put negative values, then log x will be negative. Then we cannot do that.
Sorry, can you tell me which step actually? This step?
Yes, sir.
Uh,
If we put negative values of x, then function will not define. We have to also state that it must be greater than 0. X must be here in first case.
in first.
When we are changing in exponential function, we have to specify that x should be greater than 0, because if this doesn't, then log x will.
Yeah, correct. Yeah, correct. So yeah, correct. I made a mistake here. Okay, so yeah, whatever you are saying is correct. So yeah. So again, this log 10x is less than 3. So that means x is less than 10 to the power 3, but certainly x can't be negative, because if I consider the negative values of x, then this is basically not defined. Okay. So this should be 0 to 10 power 3. And this should be 10 power 3 to infinity. Okay, so that means the total region for which this function is defined, it's which is same as the values of x for which this thing is positive. Okay, the value of x for which this thing is positive, and which is precisely as this region union this region. Okay. Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay, so let me now probably so again, like so since I solved question number 3 and 5, I suggest you to try question number 4 as well. Okay, so in that case, probably you will get uh, you can yeah, basically you can see what you have learned. Uh, let me uh, let me go to 6.2 question number 3, then I'll come to question number 2. Okay, because question number 2 is slightly different. So question number 3, what
Sir, well, my only doubt is if anything is there inside the log, right? Like uh, anything could be the base. I'm not concerned about that. If it's x, I mean any kind of odd degree over there. So it is 1 1, right?
sorry, no, I didn't get your question.
So sir, what I'm trying to say, if it's ln x or log base 2 of x,
Mhm.
if that is x cube or maybe x to the power 5, any kind of odd degree polynomials, we are taking the composite function like that, so it would be 1 1, right?
No.
Or it does
No.
have some
So
different.
the thing is, okay, so you have to make sure that so the thing is, let me tell you, I don't know. Suppose you have two function, okay, f and g, okay. Okay, so if both f and g are injective, that means, I guess that is what you are asking, injective or 1 1
Yeah.
1 1, then only you can say that f compose f is 1. Okay, otherwise this doesn't hold in general. Okay, so for example, let me tell you, like it's quite easy to see. So you take this log function, right? So suppose f is log of x, right?
Yes, sir.
Let's say g of x is x square, right? So then if you compose, what you will get? What is f compose g?
Log x square.
Log of x square. And what is the domain of this function? Now it should be g. What is the domain of this function?
Sir, sir, the range of g of x, that would be
No,
the
no,
oh, sorry,
no.
the
I
that would
want
be
the
the
range of, sorry, not range, the domain of this function.
domain.
Okay, I have explained you much more difficult cases, so you should now
Yeah.
able to solve the easier one.
Mhm.
It will be real.
Any real value, sir?
No,
0
incorrect.
to infinity.
In
Excluding zero. Excluding zero.
Correct.
R minus
excluding 0,
0.
yeah, excluding 0, yeah.
Don't again, like, don't whatever I see. I told this thing. I was trying to tell this thing multiple times, right? Uh, don't forget this thing. Okay, this log of star is defined if and only if this star is greater than 0, right?
Yeah.
So what is your star here? That first you have to find what is the star here. What is the star here?
X square.
Yeah.
It has to be
So
greater than 0, yeah.
this function is defined if and only if x square is greater than 0, right?
Yes, sir.
So x square is greater than 0 for all x except 0, right? So
Yes,
basically,
sir.
x square is greater than 0 for all x in R except 0, right?
Yes, sir.
So that means the domain of this function is what? The domain of this function is minus infinity to 0 union
0 to
0 to
infinity.
infinity. Now, if you see this log, this is the injective function, right?
Yes, sir.
This is basically the way we have defined. Okay, because see, as you see, if you go back and try to think, this is actually what? This is this is the exponential function, and you know that actually exponential function is injective, right?
Yes, sir.
Exponential function is injective, and log is what? Log is basically inverse of,
The inverse of that. Yeah.
yeah. So inverse of a injective function, inverse
Will
of,
always be the injective function. It will
correct,
always be the.
always inverse of a 1 1 or injective function is 1 1, right? So that's why log of x is 1 1 function. Okay, so this is a 1 1 function, right? This is
Yes,
1 1,
sir.
and if you see, this is not 1 1, right?
No, no, it's not 1 1.
Not 1 1. So again, if you compose actually, then this is also not 1 1, right? Because if you take minus 1, right, f compose minus 1, this is what? Log of 1, right?
Yeah, log of 1.
And if you take the same thing for 1 also, you'll get log of 1,
Log
right?
of 1. Yeah.
So again, like you can't say that this log of something will always be a 1 1 function. Okay, so you have to check what is there in the place of this star. But
Okay.
the thing is, if f is a injective function and g is a injective function, then you can blindly say that this composition will be a injective function. Okay, but again, you can't apply here, right? Because this is not
Yeah, yeah,
1 1
yeah. Because g of x is not injective, so we
injective.
can't
So
do
in
that.
that case, you can't apply. Okay. And
How can
again,
we say in general?
sorry. No,
How can we generally say this statement?
there is no general method. Okay, so you have to see the thing. Okay, certainly for if I have something like this, then I can say that this is always 1 1. Okay, but if I don't have this scenario, then I have to go and check. Okay.
No, no. When this is 1 1, then how can we every time say this that f of g is 1 1?
So no, sorry, can you tell me?
If f and g both are injective, then how can we say that f of g is 1 1?
So you are saying you know that F compose G is.
No, both f of x and g of x are injective functions,
Hmm. Hmm.
means 1 1. Then how can we say that f of g will always be 1 1?
So you want a proof. That is what.
Yeah.
Okay. So like again, like see. Uh,
Sir, this is the reason I asked you just to discuss that question number 3 actually. That
okay.
just because of this confusion I was having.
Yeah. So again, it's pretty easy. Okay. So okay, let me tell you certainly. Okay. Let me, if you go back and see this function. Okay. This function, right?
Yeah.
This can't be 1 1, right?
No, this is not 1 1.
Can't be 1 1, right? If you suppose you see this graph, right? So you try to draw a line.
The horizontal
Right?
line test, yeah,
Yeah.
it fails.
No. Yeah, certainly it fails. Like
Yeah.
now, if you see x1, right?
Mm-hmm.
And this is
Yes,
x2.
sir, it fails.
So no, it fails. Certainly, it fails for this quadratic function,
Yeah.
right? So for in x1 and in x2, f of x1 is same as f of x2, right?
Yes, sir.
Yes, sir.
And as well as in x1 and x2, this composition function is well defined, right? That means x1 and x2 both are in the domain of this function, this composition function.
Yeah, true.
Yes, sir.
You agree?
True.
So now if I take F compose G of x1, right, and F compose G of x2, then I'll get the same thing, right? Because see, what
Yeah,
is
yeah,
this?
yeah, yeah, yeah,
F
yeah,
of
yeah.
G of x1, right?
Yeah.
And what is this? F of
Yes, sir.
G
Input
of
is
G of
same,
X2.
then
Yeah,
output will
yeah,
be
they would be same.
so,
They would be same.
and
Yeah.
G of x1 and G of x2, they are same, right? Sorry,
Yeah.
Sir, got it, got it.
maybe I like I wrote incorrectly. So this should be G and this should be F. Okay, I made a mistake. Okay. So basically what I am doing, so this is my F, right? So I should
Yes, sir.
write and
Yeah, like G
yeah,
of F you were trying to say,
yeah,
right?
yeah, yeah.
Okay,
So
got it,
so
got it.
what is, so basically G is what? Log X. Okay. And then it's, I should write G compose F. Okay. Right. Because F is my this function, right? X1 and G compose F of X2. They are basically same, right?
Yes, sir.
Because at X1 and X2, F gives the same
Yes,
value.
sir.
Yes, I got it, sir.
So since you asked this thing, so okay, so actually it's easy. You basically you have to do it using the method of contradiction. Okay. So the thing is, suppose this is not 1, right? Suppose this is not 1, this function. So
Okay.
this is our assumption, right? We are assuming this, correct or not?
Yes, sir.
We are
Yes, sir.
assuming this. So certainly this is true, and we want to prove that f compose G is 1. Okay, suppose let's say this is not 1 1. So if this is not 1 1, then what will happen? If this is not 1 1, then what will happen?
Yeah, if this is not 1 1, then we can we will get two values of
There exists x1 which is not equal to x2.
Yes.
and for them the function value will be same.
For which?
For f of means whatever the function is, f of g
That
of
X1 is
x1.
would be same. Yeah. The
Yes,
composite
sir.
values would be the same for the corresponding values.
Right?
Yeah.
That means f of g of x1 is same as f of g of x2. Right?
Yes.
Correct or not? So
Yes,
from
yes.
Yes, sir.
now, okay, now from this thing you can go into two cases, right? First case is, so when this is possible, if g of x1 is same as g of x2, right?
Yeah.
So if g of x1 is same as g of x2, that means g is not injective, correct or not?
Yes, sir, that is true.
Which is a contradiction,
Yeah.
because we assumed both f and g are injective. Okay, so the next is, if next case is g of x1 is not equal to g of x2, right?
Yeah.
So let's say g of x1 is a, g of x2 is b, right? So then what we are getting, f of a is equals to,
F of B
but a is not equal to,
not equal to B.
that means f is not injective.
Oh, okay, okay, okay,
So
okay. So
see,
both okay, got it, got it, got it.
so if we assume f and g is 1 1, not 1 1, then basically we can get this thing. So basically we are getting this thing. Okay, just a minute. This is my pen. Yeah, we get this thing, and from here we are getting two possible cases, and in both the possible cases we are getting contradiction. In one case we are getting g is not injective, and another case we are getting f is not injective. So in both the cases we are getting a contradiction, right? So that means f compose g has to be a 1 1 function. Is it clear?
Yes, sir.
Yes,
Got it.
clear.
Okay, so uh, let me, Okay, I guess, yeah. So I wanted to solve something, right? Which question I wanted to solve? I forgot. I solved this question, right? Yeah. Okay, so I wanted to solve 6.2, question number 3, right? Yeah. So we have 1, 2, 3 log. So now you
Sir,
have,
sir, before you solve this, I have just a little, like a small question. So we know log any base of x, if there is x, that would be 1, 1, right? Right. Let's say ln x, that would be 1, 1.
If you have x, then this is definitely 1.
Okay, so sir, my question was if we are just putting it like 3 ln's or 3 logs, and then inside that another thing, I mean the ln of x, so that would be 1, 1 as well, right?
Yes, apply the same thing.
Okay,
Apply the
so
same thing.
yeah.
So this is, it has nothing to do with two function. You can generalize into n number of function. If you have 3 injective function, okay, if you are composing 3 function injective, then definitely you will get an injective function.
Okay.
The
So we're
same
gonna
argument.
check that step by step. So 2 at a time, then again 1, then again 1, like that.
Correct.
Okay, sir.
The
So the
whole question.
question I had in that. Oh, go ahead.
So yeah, you can ask what. No, you ask. I'm just simply writing this. Okay.
No, sir. Someone was asking something, so I was like, go ahead. I can wait.
I'm not asking, I am just explaining something.
Oh, okay.
Guru
Yes,
is
sir.
nursing.
So,
Yeah.
sir, I was actually trying to ask you if that is x cube or x to the power 5, will it be still injective?
No, that is what I just now I explained this seat to you, right?
No, sir. I totally got the point. I mean, what you just tried to
Mm.
uh discuss over there. I'm just saying, like, just asking about it, like, by watching it, can we say? Because I think we can't.
Okay, in it's depend on the function. Like if this function, see here its function is very easy, right? So
Yeah,
you have
exactly.
x
X
square.
x
Okay,
squared. Yeah.
so the thing is, okay, you if you have a function like this, okay, let's say if you have a function like this, then certainly it's not easy to tell whether this function is injective or not. Okay, you have to slightly work hard to tell whether this function is injective or not. Okay, for example, this function, this is pretty easy to tell this
Yeah.
is not injective. For example, this function, it's really easy to tell this is injective because
Mhm.
this is injective, right?
Yeah.
So you are composing this injective function with this one. So eventually you are getting a injective function, right? Again,
Yes.
you are composing this injective function with another injective
Another
function,
injective function.
and eventually you are getting a injective function. Okay, so
Okay.
this is easy. As I said, this depend on the function. So this is easy. Okay, but again, this is not easy. Again, if I go and check here, this is also not easy. Okay.
Yeah.
This case, this is not so obvious, but this is not difficult because I can easily draw the graph of this polynomial.
Yeah.
That
We
is
can.
the advantage what I have. But the thing is, I can't easily draw the graph of this thing, right? I can't
Yeah.
easily draw the graph of this thing.
Yeah. We can.
And similarly, I can't draw the graph of, let's say, this one. Okay.
Yeah. This one. Yeah.
This. So yeah, so again, this question. So suppose you want to find the domain. That is, what is the question? Let me see. What are the options? Okay. Yeah. So it's clear. Like this is 1, 1, right?
Yeah. It is 1, 1.
Yes, sir. Yes,
Yeah.
sir.
So this is 1, 1, and so this function. Okay. So this function certainly it's 1, 1. So the next task is what we need to find the domain of this function, right?
Yes, sir.
We need to find the domain of the function. Okay, so this is, so again the same whatever I told you lot of times. So again, this star, right? Don't forget about this star.
Yes, star will be greater than zero.
Star would be greater than 0.
Greater than 0, right? So the next task is here. What is star here? What is star here? This is
Sir,
star.
log base 2x.
This thing, this thing. So
Oh,
you
the
have,
entire, yeah, sorry, the entire part.
this is my log and this is my whole star.
Okay.
This is my log and the remaining part is my star. So I need to find such x for which this my star is greater than 0. Right? I need to find all the values of x for which the star is greater than 0. That means log 2 x is greater than 0. Right?
Yes.
Now it's easy, right? When this is greater than 0. First, what you do? You take 2 power in
Antilog.
both the sides. Right? If you
Yes.
take 2 of this,
Yes.
if you take 2 of this, and then if you take 2 of this, what you will get?
Sir, the
Sir, it
inside
will
log
be
would be
log
greater,
base 2x is greater than
greater
1.
than 0.
So this is basically m, right?
Yeah.
So what is m here? So m is this one, right?
No, log base 2x, yeah.
Correct. That means log 2x is greater than
1.
correct 1. Yeah. So again, I'm not done. Okay. Again, I have to take 2 power. Like you have to take the power of 2 in both the sides, right?
Yes.
So
Yes.
2 power log 2x is greater than 2. Correct?
X is greater than 2.
X is
X
greater
is
than 2.
greater than.
Whenever we are taking antilog, we must have to say that star will be greater than 0 every time we take antilog.
Yeah. Because certainly, yeah. So we see the thing is 2 power x is always greater than equal to 0, right?
Yes, sir. I got it that point, but
Yeah. So basically, for all such values of x, right? For all such values of x, my star is greater than 0. That means for all such values of x, this function, whatever this function is well defined, right?
Yes, sir.
That means this function is well defined in this region, right? For in this region, 2 to infinity. Okay. And certainly if you try to draw the graph of this function, okay. So if you try to draw the graph of this function, then it should look like this. It should look like something like this. So this is my 2. This is my line 2, x equal 2. This is right. So the graph, since the domain is basically 2 to infinity, so graph should look like this. So one thing I can say that this line is a asymptote. This
Yeah, the
this
vertical
is equal
asymptote.
to, yeah,
Yes,
correct. So this line is a asymptote. So again, it's given in the question that x equal to 8 is a asymptote, which is certainly incorrect because the function is defined at x equal to 8, right? The function is defined at x equal to 8. So certainly this can't be a asymptote. Okay. So the only, since as you can see the function, the domain of the function starts at 2, so that's why 2 is the only asymptote to this function. So this is clear.
Yes, sir.
Okay, so let's go to some other question. I guess you have asked question number 3. Not question number 3, question number 2, I guess. Again, same, like the idea is basically same. 6 point. Okay, so yeah, so this is f of x is basically ln of modulus x. Now, can you tell me what will be the domain of this function?
Sir, apart from 0, any value.
Correct. The same method, right?
Yeah.
So you have star here, which is modulus of x, and star is 0. That means modulus of x is 0 if and only x is in this region. Right?
Yes, sir.
So one thing, so now for this particular thing, it's really easy to draw the graph, right? It's
Yes,
really
sir.
easy to draw the graph. Can you see this is a even function?
So it depends on the domain, right? Because mod of x is a v kind of graph if we take even, or I mean, both the values are on the real line.
So, but
So
if x is 0, if x
yeah.
is 0, if x is greater than 0, right?
Yeah.
So mod of x is what?
So
If x is
It will be greater
x,
than 0.
it'll
so this is mod of x is x, right?
Yes, sir.
If
X.
x
It will
is
be
greater
X.
than 0,
Yeah,
mod
yeah,
of
yeah,
x
yeah.
is x,
Yes.
right?
Yes, sir.
Yeah.
So if x is greater than 0, then ln of mod of x is precisely ln of x,
X.
right?
Yeah.
So then I will get this graph, right?
Oh yeah.
Correct or no?
Yeah. Yes, sir.
And this is a even function, right? Because whatever I get at 2, I'll get the same value
Same
at
at
-2.
yeah, -2. Yeah.
So I'll just get a reflection, okay, with
About
respect to
y.
y-axis,
Yes, sir.
right?
Mhm.
So I'll get something similar over here, right? This is my graph. Now you can tell everything about this function, right?
Yes, sir.
One thing is okay. Let me go this option one by one. F is a increasing function. So whether this option is correct?
No, sir, it is not.
Certainly it's not increasing. So as you can see, it's basically in this part. If you see in this part, the negative part of x-axis, this is decreasing,
Yes.
right?
Yes, sir.
And whereas in the positive part of
It is
x-axis, it is increasing.
Then it is increasing. Yeah.
So it's sort of some different kind of behavior it's showing in both the parts of x-axis. Okay, so as a whole, the function is not increasing. Okay. So the second option is the straight line x equal to 0 is a asymptote of f.
Yes, sir, that is true.
That is
Equal to 0
true,
means the
right?
y-axis.
Yeah, basically my y-axis, this y-axis, which is precisely the line equation of this y-axis is x equal to 0. This line is asymptote to the
Yes.
graph of this function.
Yes.
So the second option is correct. The inverse of f is e power mod x.
It is not true,
Whatever.
sir.
Why?
It is not true, sir. Okay, why?
Yeah, this is not true.
It's not true.
I want
Oh, the
explanation.
okay, clarification. Okay.
Sir, because sir, its graph will not be symmetrical about the line y is equals to x.
So yeah, that is not the answer I was expecting. Someone said it's not one to one. Okay, so only one to one functions have inverse, right? Only one to one functions have inverse. If a function is not one to one, then certainly it can't have any inverse. Is it clear?
Yes.
What?
Yes, sir. Yes, sir. Yes, sir.
Yes,
Definitely.
So this is not one function, right?
it should be
This is
bijective actually.
this is not one function. If you draw a line, if a horizontal line,
It fails the test.
It fails the test, right?
Yeah.
So it touches the graph at 2 points. That means at this point and at this point, the value of the function, they're same, right? So it is, so this again, right, if you see, yeah, so this function is not 1 1. Since this function is not 1 1, then simply I can't talk about the inverse. Okay, so the inverse of this function has no meaning. Okay, the inverse of a function makes sense. Okay, the inverse of a function makes sense when the function is 1 1, and some other thing is there, but the first thing is the function has to be 1 1 function, and clearly this function is not 1 1, because at -2 and 2 this will give me the same value, at -3 3 this will give me the same value. So this function is not 1 1, so that means it has no inverse. Okay, clear? Option number 3, that inverse of, why the option number 3
Yes,
is
sir.
incorrect.
Yes, sir.
And certainly option number 4 is more or less clear. The domain of the function is -infinity to 0 union 0 to
0 to
infinity,
infinity.
which is pretty obvious, because again the same thing, star, you apply using star and you do it.
Yes.
Okay, fine. Okay, so any other doubt you have? Because probably, like I almost explained, probably I'll go to some other activity part also. I just don't want to spend all my time in 6.1 and 6.2. But okay, before that, I just want to ask, is there any doubt from, any other doubt from 6.1 and 6.2 which you want me to solve? Again, I'm not going to solve 6.4 because I have already solved question number 6.1, question number 4, because I have already solved 6.1, question number 3 and 5. So you should try question number 4. Okay.
So 6.2, question number 2, sir.
Question number 2 I have solved
Done,
just
done,
now.
done.
Sir,
Just
actually,
now
I
I
was
solved.
late, so that's why I'm asking it. If
That
you have,
certainly you can
if
ask
you have
if
solved,
you
then
can.
well and good, sir.
No, I took lot of time to solve this. Okay, you can see the
Okay,
record.
sir. No, I will be watching the recording, sir.
Yeah.
And question number 3, sir, 6.2, you have solved.
Yeah, that is also I solved. Okay.
And 6.3, number 1.
Okay, let me see what is the question. Yeah, 6.3, number 1. Okay, that is a good question. Let me do it. So it's better for me to. Okay, so just give me a minute. I'll go to that particular file. Yeah, my screen is visible, right?
Yes, sir, yes, sir.
Yeah.
Yes, sir, it is visible.
So this is the question, right? This is the question which
Yes, sir, yes, sir.
you asked. So this question is slightly different, slightly different from the question that I've already solved, but not much difference. Okay. So it's saying that the domain of this function, whatever it is, I don't care what it is, but I have a function f of x, and the domain of this function is -3, 1, right? F is a function from -3, 1 to r, right? This is my function. And what I want to do, I want to compose this function. Okay, f composition with ln of x, and I want to find the domain of this function. Okay, so My next question is, if ln of x is 5, if ln of x is 5, whether this expression has some meaning? Any answers?
What is it, sir? Again, come again, sir.
If ln of x is 5,
Mhm.
whether this thing has any meaning or not?
Then it can be written as f of 5.
Yeah, f of 5.
Won't
But
be defined.
But f of 5 has no meaning
No
because
meaning.
f is
5 is
not
not in the
defined
defined.
at 5.
Yeah, it's not
Okay.
defined.
So basically, to say that, to say this function is defined, okay, I have to find the values of x, right? I have to find the values of x for which my ln of x is basically in between -3 to 1, right?
Yes, sir.
Yes,
So
yes,
if ln of x will lie beyond of this interval, okay, then certainly this has no meaning because f is not defined beyond of this interval. So I need to find all the values of x for which ln of x is precisely in this interval. Okay, and when ln of x will be in this interval, you just have to see what is this meaning, what is the meaning. Okay, try to understand the meaning. This is basically what ln of x is less than 1 greater than -3, right?
Yes.
Yes, sir.
So now you take
E to the
power
power of. Yeah.
e power in both the sides, right? Both the sides. If you take -3, this is x, this is 1, correct or not?
Yes, sir. We can do that.
So we are done then. Basically in this range my composition function is defined because in this range my ln of x will land inside this interval, so that's why my
So
composition makes sense. So this is the domain of this function. Clear? Whoever asked this question? Okay, fine. Okay, any
Sir,
other
I
doubt?
have a doubt
Mhm.
in the same thing. Like, if it is a composite function, then ln of x, the range of ln of x should be in this interval, isn't it, sir? Or the domain.
No, that is what I'm taking the range, right? So what is ln of x? ln of x is basically in the range, right? This is basically in the range.
So you're talking about the range. So this is the range, isn't it, sir?
Which one?
You have written like this -3,
Yeah,
comma 1.
so the thing
So
is, yeah, so when I'm talking about this composition, F compose G, okay, F compose G. So then basically see this G of x so this thing makes sense when G of x is basically inside the domain of F, right?
yes.
So G of x is basically is a element in the range of G, right? X goes to G of x. This is basically is a element in the range of G. So I want to find all the values of x for which G of x, G of x, G of x is a element in the range which is in domain of F.
Oh, okay.
Okay. Okay, any other doubt?
And sir, number 10 also, sir, how to approach it?
Okay, so number 10. So,
Like graphically, how we can approach the question.
okay, just a minute. It's like when you joined the session.
Sir, actually, I joined it late, 1 hour.
No, like, okay, 1 hour later you joined. So you joined around 9, right? So then
Yes.
so the why, because why actually I'm asking, I want to ask some question because I have explained so many questions related to law. Okay, so again, like as I already explained, it's not easy to draw the graph. Okay, so why it's not easy to draw the graph? Because it's not easy to draw the graph of this function. Okay. That is the problem. Okay.
Hmm.
So that's why it's not easy to draw the graph of the whole function. Okay. So, okay, so just a minute. Yeah. So this is my function, right? So my function is what? E power x. I guess this is e power x minus e power minus x, right?
Yes, sir.
Correct or not? So
Hmm.
again, let me tell you again. So if you want to draw the graph, then it's really difficult to draw using any software. So there are few different way of doing these questions. Okay. So one thing uh, we need to find first what is the domain of this function, right? Correct or not? Hello.
Yes, sir. Yes, sir.
Yeah, so this is basically what? This is composition of two functions, right? This is ln of x and another function. So this is ln composed f of x, where f of x is e power x minus e power minus x. So I want to find the domain of this function. So again, what I have to do? What is star here in this case? What is the star for this function?
So e to the power x minus e to the power minus x.
Correct.
It will be greater than 0.
So this function is defined if and only if e power x minus e power minus x is greater than 0. So to find the domain of this function, what I have to find? I have to find all the values of x for which this thing, this inequality holds, right? So as you can see, what is this? This is basically what? E power x minus 1 by
1 by e power x.
which is greater than 0. So one thing you know that e power x is never 0, right?
Hmm.
Correct or not? Because if you see the graph, it never touches the x-axis, right? See the graph, this graph never touches the x. So e power x is not 0. So I can write, right? E by 1 by e power x. Okay. So what next? What I will do? I'll multiply e power x on both the sides. Okay. So and another thing also, you know, e power x is always greater than 0. Correct or not?
Yes, sir.
Yes, sir.
So if I multiply e power x with this thing, right? If I multiply e power x with this thing, then certainly it will not reverse the sign.
Yes, sir.
Yeah, the sign will be intact.
Correct. So then what I will get? E power 2x minus 1 is greater than,
Greater than 0.
that means e power 2x is greater than 1.
1.
So now can you tell me what will be the
Log
values
on
of,
both sides.
So
sorry?
taking log on both the sides. ln.
Natural log on both sides.
So yeah, so I just correct whatever you're saying, correct. But what will be the final what will be the
That
range of
X
x?
is greater than 0.
finally it will be that x is greater than 0.
Correct. Yeah, absolutely correct. So from here we can get that x is greater than 0, which is basically x is in between 0 to infinity.
That second line, e power 2x minus 1, how we got, sir?
This line, right? We are talking about this line.
Yes, sir. Yes, sir.
So we have multiplied e power x. here, right? We have multiplied e power x here. So if I multiply, then what I will get? E power x
Separate. Okay.
times e power x minus e power
Minus
x by e power x,
I.
right?
Okay. Okay, sir. I think I got it.
Yeah.
Thank you, sir.
So, okay, so this is the domain of this function, right? This is the domain of this function. So domain of this function is, okay, so domain is basically what? 0 to infinity. So now if you see, I have two other options. Okay, so this option is certainly incorrect because domain of f is not R. So we have two more options. Okay, and as you probably know that if f is a increasing function, okay, if f is a increasing function, then certainly it's 1, right? If f is
Yes,
a
sir.
increasing function,
Yes, sir.
then
Yes, sir.
certainly it's 1 so let me do it. Let me check whether f is a increasing function or not. So if I somehow if I show that f is a increasing function, from there itself I don't have to go and check whether it's a 1 function or not, because from there itself I can say that f is a 1 function. Okay, so let me check whether this function is a increasing function or not. And for uh, to show a function is increasing, what I need to show? To show a function is increasing,
Greater
what?
You can
value.
differentiate it.
Yeah, so I want some mathematical answer. Okay, whatever you are saying is correct,
If,
but
if we increase the x value, y value should be.
Yes, sir. Yes, sir. That.
yeah, in some sense, yeah. Okay, you have the idea, but okay. So basically, what I wanted to know that we have to show that if x is greater than y, okay, let me use some different thing. If x1 is greater than x2, then this should imply that
y1 is greater than y2. Oh, sorry, yeah, the function value would be greater than the next function value for the corresponding value.
yeah.
I was about to say y.
Yeah. So that certainly that makes sense. So yeah, so basically this is more or less this is y. So this is right. If I show this, then this should imply that f is a
Increasing function.
yeah. So actually, it should be greater than or equal to, and this should be greater than. So strictly greater than sign comes when you have a strictly increasing. So somehow I want to show this thing. Okay, somehow I want to show this. And if I show, then basically I am done. Okay. I show this, then
So in
basically
the equation, we can substitute 2x value. One is 1 or 2 like that.
sorry. So that certainly you can't do actually. So because see the thing is
Sir,
that
we need to be generalized.
yeah. So that if the domain is finite, okay, then only you can do that, right? So if the domain is infinite, then certainly you can't do it within a finite time, right? If you start with some number, you start 1, 2, no, this isn't correct. 2, 1, then 3, 1, 4, 1. Okay, then it will never stop. Okay, because you have to check for all such x1 and x2 such that x1 is greater than or equal to x2. Okay, so you have infinitely many possible choices. So if you check one by one, then it's never going to end. Okay, so you have to use a general method. Okay, so without that this is not possible. Okay, that so this you can take fixed value when your domain is a finite set. For infinite set, that procedure won't work. So
got it.
okay, so again, like so before that, just let me ask you: do you agree that exponential function is an increasing function?
Yes, sir, it is.
This is right, because the graph, if you see the graph, then this is basically increasing. If you see, if you increase the value of x, if you increase the value of x, that means if you are going towards the right side of x axis, then as you can see, the value of the function is increasing. Okay. The value of the function is increasing. So this is an increasing function. So okay, what I'm doing.
It can be decreasing also when negative sign is there.
No, this is increasing in whole R. As you can see, this is so this is decreasing, right? Sorry, this is increasing, right? The function is increasing.
Yeah. Sir, but exponential functions can be decreasing also.
Exponential function can be decreasing, but I'm only talking about
Okay,
this
this case.
e power x. Okay, so if you are talking about a power x, okay, then this can be decreasing. This function can be decreasing if a is less than 1. Okay, but if a is greater than 1, if a is greater than 1, then this function is increasing, which is the case here, because e is greater than 1, right?
And if the x takes negative value, if e to the power is minus x, then sir, it will decrease.
What is your function?
E to the e raised to minus x.
So yeah, correct. It will decrease. Okay, it is a decreasing function.
Yes.
Because it's so what will be the graph of this function? What will be the graph of this function?
Yeah, opposite side of reflect.
It will look
Reflection about y-axis.
correct. So it will look like this, right? So
Yes.
as you can see, if you increase the value of x, if you
Yes.
increase the value of x, the value of f of x is basically it's going down and down. So this is a decreasing function. This is a decreasing function. Okay, but again, like we are not concerned about this function. We want about this function, and this function which is increasing function. Okay, e power x. So e power x is increasing function. So that means I can write what I can write if x is greater than equal to x2. That means I can write e power x1 is greater than equal to e power x2. Correct?
Yes, sir.
Now can I write e power minus x2 is greater than e power minus x1?
Yes, sir. Yes, sir.
Which is again sort of
Yes, sir.
It is, sir.
obvious, right? Okay.
Yeah, it is true.
See again, like I can also see what I did. I started with this thing, then I came here, then I came here. Okay, even I can directly from here to I can come to here, because this, from using this I can write minus x2 is greater than equal to minus x1, right?
Yeah. By multiplying both sides, so the
Minus
inequality
1 goes
sign change, the sign will
and
change. Yeah, true.
and then I can use the fact that e is a increasing function. So in that case, e power minus is greater than equal to minus 6. So eventually I'm getting the same thing. Even I can come from here to here using this by this step, or I can come from here to here by this step. Okay, they are basically the same thing. Okay. What I did. Yeah, fine. So again, what I want something different. I want e power x minus e power minus x. E power x minus e power minus x. So basically I want something like e power x1 minus e power minus x1, right? And I want something like e power x2 minus e power minus x2. Okay, then I can come somewhere near to this thing. Okay. Right? So till now this is fine, right?
Yes.
Yeah. Okay, so let me go back to the domain. So what is the domain of this function?
0 to infinity.
That means this x1 and x2, right? This x1 and x2, they are always inside 0 to infinity, right? Correct or not?
Yes, sir.
Yeah. So now one thing, now I can say that e power x1 is greater than e power x2, right?
Yes, sir.
Yeah. And one more thing I want to tell, that yeah. So just a minute. Let me see what I have done. Maybe I have made some mistake.
No, so no.
Sir, that would be reverse, no? I think I might be wrong. Sir, the last line. I think I need to check. I guess. Okay, sir. I'll just try.
Just a minute. No. I guess this is fine, right? Because
Sir,
what
this is fine.
Yeah,
if
yes, sir.
A,
Yes, sir. Yes, sir.
if
This is
A
fine. That
is
is fine.
greater than A is greater than B, okay, then the reciprocal 1 by B should be greater than 1 by A, right?
Yes, sir. Yes, sir. That is fine.
Because
That
if
is fine.
the number is small, then reciprocal is basically it's big.
Yes.
Yeah. Okay. Yeah. So uh, and the thing is, what I want to do, I want to bring this thing over here. Okay. E power x minus e power minus of x, right? This somehow I want to bring, right? Yeah, that is what I'm thinking. E power x minus e power
Yes, sir. Yes, sir.
minus x. So this now I have e power minus x and e power minus x1. Okay. So yeah.
Yes,
And
yes, sir.
What we can do is e power x1 is greater than equal to e power x2.
hmm,
So the right hand side bring it to the left and e power x1 minus e power x2 will be greater than equal to 0. The same thing
Sorry,
we can do.
can you tell me what you are suggesting?
E power x1 is greater than equal to e power x2. So
Yeah, which is
what we can do is e power x1 minus e power x2 is greater than 0.
yeah.
Minus, yeah. Same thing for the second equation as well.
Which one? This one.
Yeah.
This one, e
Yes.
power
Minus x2 minus e power minus x1 is greater than 0.
greater than
Equal to
0.
0.
Yeah,
And add these
And
both.
then we will add them.
correct. Yeah. This is, let's say, equation 1, and this is equation 2. So now what? Equation 1 plus equation 2, right? So if I add these two things, what I will get? I'll get e power x1, right, minus e power minus x2 plus, sorry, I made mistake. E power x1 minus e power x2 plus
E power
e
x
power
minus x
minus x2 minus
e power minus x2.
Minus x.
which is
Greater than 0.
0, right?
And
Yeah, correct.
bring the
Now it's certainly it's a bit obvious. So now, as you can see, that whatever now basically what you want to do, we want to bring in one side we have x1 and another side we have x2, right? So now we
bring
just
the second and third term to the right hand side.
yeah. So we just need to bring this term and this term together, and this term and this term together. Okay, so basically if you see, e power x1 minus e power minus x1 is greater than equal to e power x2 minus e power minus x2. Correct or not?
Yes, sir.
Yeah,
Yes.
I think it's correct. Yeah. So basically we have started with this thing, right? X1 is greater than x2, right?
Yes, sir.
And we reached here, right?
Yes, sir.
Now, so what is our function? Function is ln function, right? That means log base e, right?
Yes, sir.
So log base e is a increasing function,
Yes,
right?
sir. It is increasing.
So
Yes, sir.
so now again we need to apply that thing, that this thing is greater than this thing, right? That's why log of this thing is
Will also
greater
be
than
greater than.
this thing.
Yes, sir.
That means log base e one is greater than log base e. So okay, instead of ln e, actually I am writing log base e, right?
Yes, sir.
And this is precisely my f of
x1.
x1, and which is greater than equal to
F of x2.
f of x2. Okay, and and the thing is, by the same procedure, if x1 is strictly greater than x2, okay, then I can get a strictly sign. F of x1 is strictly greater than f of x2. That means f is a strictly increasing function. Increasing function. So this is since this is a strictly the increasing function, that means
Yes, sir. That
it is
means
1
it is
1.
also 1 1. Yeah.
It would be 1 1.
Sorry. So okay, I started with this question here. So that means this option 1 and option 3 are correct. Okay. So this question number 10 is clear.
Yes, sir.
Okay, I guess, is there any other doubt? I guess probably I solved question number 9 and 10. Okay, question number 11 is more or less easy. There is
Yeah, it
nothing
is
to,
easy.
yeah.
That one is easy, sir.
What about question number 12?
That is easy.
Yes, sir. This is
Already
also
did, sir.
easy.
Yes.
Yeah, we have done. 2 is answered. I guess.
No. This part I guess is not done. Question number 12.
We solved
Okay,
it
so
yesterday, I guess.
okay,
Yesterday,
yesterday.
yeah,
Yeah, yesterday.
Yeah, then
yesterday
it's good.
or previous session.
Yeah. Okay. Okay, I guess this is also like more or less easy. This is also easy. Number 15 is more or less easy. Same thing. It's basically you need to apply this rule, log A minus log
Yes, sir.
B.
This is also done.
Yeah. Log A by B. This will give you the solution. This you should try. It's more or less.
We solved it yesterday.
Yeah. So the just let me tell you the yeah, since you have solved, let's just give me a minute. I will spend just maybe more, maybe a minute. So the thing is, if you have a number, so the main idea is if you have a number with k plus 1 integer, right? If you have a number with k plus 1 uh, integer, means what I'm saying, suppose this is a number with 3 integers. Okay. So and this is some
K plus 1 digit means.
sorry, yeah, sorry, digits here. So this is a number with 3 digits. Okay. So if you have a number with k plus 1 digits, then one thing is sure that it will always lie in between 10 power k and it should be less than 10 power k plus 1.
Yes, sir.
So all you need to do, we need to take log base 10, okay, to get this. So that is the idea. To get the number of digits of this integer, you just need to work with log base 10. And obviously, like you have to also, because if you take log base 10, then you will get k. Certainly you are not going to get k plus 1. So for that you have to add one more thing to get the number of digits of this integer. Okay, this is more or less this question, like there is some formula and you just need to apply it. And yeah, this is slightly tricky.
Sir, but that
Yes.
formula, if we are not knowing, then how can we do, sir?
I guess Sar has discussed this question, right? This kind of question.
When
Yeah.
e power x, I mean, that was shown to us, sir.
Yeah. If you don't know, then certainly you can't do it. Okay, because yeah, so then you have to derive that formula. That is also some that is not that easy. Again, that is not too difficult, but again, that is also not that easy.
Okay.
Yeah. So again, you have to use the you have to take the help of this the question that are discussed in his
Yeah,
lecture.
that is coming in the 5th week, sir, last lecture.
Yeah.
Okay, sir. Thank you, sir.
Yeah, so I'm just vaguely discussing few things, like I'm not going to do anything more rigorous. Okay, so this question also, it's more or less related to this change of base formula. Okay, so probably if you don't know, then you probably will see. So this is more or less related to this one. Solving this question is.
Yes, sir. This thing also I think done in previous session.
Yeah, I'm again, like I'm not going to solve this question. I'm just giving
Okay.
idea. Yeah, this is tricky. You should try to do it. because I have discussed a lot of things related to graph and all these things, but yeah, this is tricky. Okay, so let me, I don't want to continue any further if you don't have any doubt. Is there any other doubt which you want me to address? Okay, then probably I'll stop.
Sir,
Yeah, please.
sir, just one thing, sir. I just cannot get this thing out of my head. I mean, for any logarithmic function, is there any trick? Since like I started with the same question when you started the session, how can we at least say this is nearly equal to any kind of function of if we see a graph? Because he said it's pretty hard, and he just showed us that. I mean, it's very hard. So
no, it's depend.
for
Actually, it's depend the hardness of the star, right? This star.
yeah. So, sir, you see, sir, if it's like any quadratic or any raised to 3 power, we can just assume at least like how will it go, because we know how to plot that.
Yeah. So as I
We
said,
will
like
put some values and then we will join.
yeah. So
very
you
smoothly
just
like
need
that,
to
sir
put some values
explained
and
it in the beginning.
yeah, you just need to take some values. Again, so again, like
Okay,
it's
so sir, that's the only way, right?
yeah, that is
Okay,
probably the only way that I know.
okay,
So,
okay. Because
One more thing.
sir, sir, for like let's say we have 10 factors, so that would be pretty tedious, right? I mean, to get those values, I mean the points. So that's why I was trying to.
sorry.
So, sir, let's say we have like 10 factors inside log, like 1 plus x plus 1, x plus 2,
difficult
like
if you
x
take
plus
it.
10. It would be
Yeah,
very hard in that
yeah.
case. So
It's
that's why.
really, it will be really difficult. Forget about like if this factor. It's let me tell you this drawing this graph. Okay, it's really difficult. Okay, at least.
Sir,
Yeah.
All right, sir.
sir, I don't know. I would have missed. Would have told. What is the star you're telling, sir? I couldn't. Not attended that session. Maybe.
Okay, I'll suggest you can rewatch the session. Like
This session, sir. Today's session.
yeah, it's my whole
Okay, no
session is
problem.
all about star. Okay, so
That's okay, sir. I will see in YouTube.
yeah.
Thank you very much.
Yeah, thanks. Okay, then I'll stop the session now. If you have nothing
Sir,
else,
I have doubt in some week 5 activity questions.
yes, ask me. What is your doubt?
Sir, it was activity 5.1 question 4. So actually, sir, here a one-to-one function is always reversible, isn't it?
It's always reversible.
Sir,
One-to-one function.
but sir, there in question number 4, activity 5.1, sir, you see once,
Then actually this is a general mistake most of the people. It's asking about the
Oh,
false
sir,
statement.
it's a false statement.
Yeah, so that is what I'm saying. Like it's basically it's because of this question. It's the mistake of the question. Like it's asking you to find this false statement. Okay. Which is
if
the
a
following?
if a function fails horizontal line test, it is always
It's not 1-1.
it's not reversible, isn't it, sir? Okay, then it is wrong
Correct
written
statement.
there.
Right? It's not. Yeah.
Yeah, and one more, sir. Activity 5.2, question number 4 again.
5.2. Question number 4. Yeah.
Yes, sir.
Which option you have problem?
Here, how fx is equal to 4x plus 3 by 3x minus 5.
Is
How
1-1,
is it?
right?
How
1-1,
is
right?
it? Yeah.
That is what you want to know. Okay, let me do it. So can you tell me the function again? F of x is equal to
4x plus 3 by 3x minus 5
4x plus 3
divided by 3x minus 5.
3x minus 5. Okay.
Yes,
Okay,
sir.
so certainly this the
For
domain,
all x
yeah, in the domain of x.
in the domain of real numbers.
Domain of a function. Real number don't have domain. Okay, so this is basically r minus
So
Yeah,
5 by 3,
3
sir.
yeah, correct. 3. I was
yes, sir.
writing 5 by
5 by 3.
this is the domain. Okay, so basically you need to show that this is 1 1, right? That is what
Yes,
you want to show. So for 1 1, what you need to show?
yeah, it is it should pass the horizontal line test.
So
Means
again, so the thing is that actually you can apply one if you can draw the graph of that function, right?
it turns to be quadratic.
No, it's not quadratic. It's not, certainly it's not quadratic. So again, if I try to apply this horizontal line test to know whether this function is 1 1 or not, then I'm basically done. I can't do that because it's really difficult for me to draw the graph of this one. So I have to go with the theoretical procedure. Okay, so if you try to draw the graph of this function, then certainly the graph of the function is not drawing the graph of this function, I guess, is not that difficult, but again, it's not that easy also. Okay. You can simply do it directly, right? So you know, if you can show that
So
if f of x1 is equals to f of x2, and if this should imply that x1 is equals to x2, then f is 1 1, right?
yes, sir.
So we just need to show that if this is true, then this is also true. That is what we need to show. So which is actually easy. Suppose f of x1, what is f of x1?
4x1 plus 3 upon 3x1 minus 5.
And this is 4x2 plus 3
upon 3x2 minus 5.
Yeah, 5. And since x1 and x2, they can't be 5 by 3, right? That is because x1 and x2 are in the domain, and in the domain, I don't have 5 by 3. Okay, so since x1 and x2 can't be 5 by 3, that means 3x1 minus 5 and 3x2 minus 5, they are not equal to 0. So that means I can multiply the inverse. Okay. That
Yes,
means
sir.
4x1 plus 3 times 3x2 minus 5 is same as 4x2 plus 3 times 3x1 minus 5, right?
Yes, sir.
Correct or not? So
Yes, sir.
now actually you try to multiply. If you, okay, let me complete it. So this is 12 x1 x2, right? And 20 minus 20 x1, this is 9x2, yes. This is 18. No, sorry, not 18. This is minus 15.
15.
Yeah.
15 is equal to 12 k1 k2
Yes.
x1 x2, sir.
This is again 20 x2. Then I have
9
9x1.
1
Then I have
minus 15.
minus 15. So now what I can do, I can cancel this one, I can cancel this one, I can cancel this one, I can cancel this one. So once I cancel, what I have minus 29x1, right? And minus this is plus 29x2, right? Is 0. Correct, right?
Minus
Yes, sir.
29.
I'm just taking this one.
Yes.
For,
Yes,
so,
yes.
so from here it's clear, right? X1 is equals to X2.
Okay, sir. Can you just make it clear how if k1 if x1 x2 is equals, and how it is 1 to 1?
If X1 is equals to X2, so
Yes,
that
sir.
is one of the definition, right? So what is the definition of 1 1 function? Tell me.
Sir, if for any value of x1, when any single value of x, there should not be sorry, for any single value of x, there should be always be distinct value of y.
No, no, no. You are far from correct.
So okay, sorry, sir. For every y, there should be a single x.
For every y, there should be a single x. Yeah, in some sense it's correct. But again, this every y is little problem. Means this is
For
slightly
on
problematic. For every y,
Every
there
y
is
in
a
codomain.
yeah, that is correct. Yeah, that is correct. That is precisely. But again, you are saying some whatever you are saying is correct, but you can say it easily. Like you are going into more complicated definition. It's for every y in the not codomain, not codomain. Every y in the range, not codomain.
yes,
Because if you are taking in every y in the codomain, then basically you are saying this function is onto. If for every y, if every y in the codomain, if if I have only one x here, then basically you are saying this function is both 1 and as well as onto. That is, you are giving the definition of a bijective function. Okay, that is not the case. Okay,
Yes, sir, got it.
so the thing is, so one of the definition is if x1 is not equal to x2, that means if my inputs are different, then my output are also different.
Must be.
yes, sir.
Yeah, must be different. Should be different for 1 function. That is the definition of 1. A function is 1. If my inputs are different, then my output should be also different. Okay. For example, if I take this function x equal to x square, this is not 1 because if I take two distinct input, then my output are same, right? This is output are same. F of x1 is 4, f of x2 is 4. So this is not 1 function. So for 1 function, this condition should hold. But but what actually I have done here, okay? What actually I have done here, I sort of proved the contrapositive of this statement. So what I proved, if f of x1 is equals to f of x2, then this should imply that x1 is equals to x2. So now you try to think why these two conditions are same. Okay. I have discussed this
Yeah,
thing
I
multiple
understood,
times.
sir.
Yeah. So and precisely I have proved the second step. This condition. So initially I assumed that f of x1 is equals to f of x2, and what I have concluded that x1 is equals to x2. That means that my function is 1.
Right, sir. Right, sir.
Yeah.
Yes, okay, sir.
Yeah.
And sir, one more. Activity 5.3, question 4. Here it is.
Question number 4. Yeah. What is the issue here?
Sir, for all a raised to the power 0 is equal to 1.
Yeah, this is incorrect,
For
right?
all,
Because 0 power 0 is undefined, right?
yes, sir. It should
So
be correct, but here it is not.
no. It is what is written. A power 0 is 1 for all a in R, right? This is what
Yes,
it is written. That means it should prove if this statement is correct. You are saying this statement should be correct. So that means
yes,
if it is correct, then it should be correct for a equal to 0, right? It should be correct for a equal to 0, right? That means you are saying
yes,
0 power 0 is 1, right? But second option is incorrect, right? 0 power 0 is undefined. So that means this option is also incorrect. Clear or like?
no, sir, it is not
No,
clear.
what basically it's saying? It's saying a power 0 is 1 for all a in R, right? For all
Yes, sir.
values of a in R, this should be correct. right? That is what
Yeah.
this option
Yeah.
is
Yeah.
saying. That
Yeah.
means
Yes.
in particularly, if a is equal to 0, if a equal to, because a equal to 0 is also a real
Sir,
number,
0
right?
power 0 is 1. I think.
Sir, it should be correct. Matlab this statement should be correct.
That is what I am trying to explain, right? So what is the statement is saying? First tell me what is the statement is saying. A power 0 is 1, right? So
Yes.
what is your question? You are asking question on option 2 or option 3?
Sir, here an answer is here it is asking that which is incorrect.
Yeah.
So
So
I have not checked this. So my answers should be right, but you see the answer in answer. This is also there. So
yeah, because this is an incorrect statement, right?
0 power 0 is not 1.
Sir, 0
Zero.
power 0 is 1.
Okay, it's what actually in lecture what's are defined? Is there anything are defined in the lecture?
What?
Is there anything sir defined it in the lecture? Whether sir discussed anything about what is 0 power 0?
No, sir, I have checked on scientific calculator just now.
No, okay, scientific. Okay, so there. Okay, so it's depend on the convention. Okay, so in most of the calculus actually 0 power 0 is undefined. Okay, mostly if you go to combinatorics, then probably you will see that 0 power 0 is 1.
in lectures also, this is not nowhere. This is clearly told.
Okay, okay.
So I'm asking again, sir. Let me
So
make it
one,
clear.
okay, so if you
This
agree,
statement is incorrect or correct?
if
To
you so it's actually it's depend on what you think. So do you think this is
I think this is
this
correct, sir.
this statement is correct?
Yes, sir. I as per
Sir,
my
we are multiplying 0 times.
No, 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 no. I am not multiplying 0 times. Okay.
What
So
we are doing.
so okay, so there maybe you'll see if you study calculus. So there is lot of problem of assuming 0 power 0 is 1. Okay, so probably in combinatorics you can assume that 0 power 0 is 1, but certainly you can't assume 0 power 0 is 1 when you are doing calculus, which basically you will see in your upcoming term. Okay, so if you think this is correct, that means 0 power 0 is undefined, okay, then this can't be correct. A power 0 is 1 for all a in R. If this is correct, then certainly this is incorrect.
Yes, sir, but this is just convention.
Yeah, that is what I am saying.
what conventions are this?
Actually it's depend, like, see, so the problem if you see actually, so sometimes people they take 1 as a natural number, they start natural number with 0, and sometimes they start natural number from 1, right? So it's depend what you want to study in your course. Okay, if you are doing some, if you see, so basically, so till now, uh, till week 6, okay, if you see till week 6, okay, 0, we are including 0 as a natural number, right?
Yes, sir.
So once you start reading week 7, once you start calculus, okay, so in the first lecture itself, Professor Sarang said we are not including 0 as a natural number. Okay, because if you take 0 as a natural number, then each and every time you have to say some few extra thing. Okay, and he don't want to do that. So from the beginning itself, uh, he want to exclude 0 from the set of natural numbers. So that is in some sense is convention.
It will
Now
come
in
in the
lecture,
limits.
it is, Sir has told, sir, 9.42 seconds. Definition of exponential function is given such that a is more than 0 and a is not equal to 1.
Yeah.
A to the power of x.
Yeah. So for particularly for this course, actually, we are taking this 0 power 0 is undefined. Okay. So if
So
It will come in the limits, right? Where It will be an indeterminate form.
Yeah.
Indeterminate. Yeah, that is the word. That is the word sir has used. Lecture
Yeah,
5.3 at the 9 point seconds, sir.
Yeah, so I'll suggest, yeah, you can check the lecture 5.3. Okay. As someone is suggesting, try to see the lecture. Probably Sir has mentioned this. Okay, so
Yes, sir, I
Which
know
lecture?
about that.
Which
I am
lecture?
asking about 0 power 0.
5.3.
5.3. Yeah.
Lecture 5.3.
Yeah.
Okay.
So
Sir,
again, let me repeat. If this is undefined, okay, 0 power 0 is undefined, then this option is incorrect. Okay. Because
okay.
it's saying a power 0 is 1 for all a in R. So in particularly, if I take a to be 0, then also it should hold, right? But 0 power 0 is undefined. It's not 1.
So for only for one value, this is undefined. Rest all it is
So
one.
if instead of this, if I change that this is true for all a in this set, then
Zero.
this
Yeah.
statement
Then
is
it
correct.
is
Statement
okay.
is correct. Okay, because I'm excluding 0. Okay, and apart from that, 1 power 0 is 0. If instead of 1, if I have any non-zero a, then if I have any non-zero a, then this is 1. But when I'm saying a for all a in R, at that time I am also including a to be 0, and which is not. Okay, is it clear now?
Yeah, sir. It is
Yeah.
clear.
Okay.
Sir, more.
No, but in sir is telling even the real line 0, comma, I mean, 0, comma 1, it's an open bracket, sir. So 1 also is not included in exponential function.
One
0,
is not included in a exponential function, but 1 power 1 is 1. Okay, 1 power 2 is 2. Okay, so we are not considering as a exponential function. So that is a something different.
different. Okay,
Yeah.
okay.
It's constant function, right? It
Yeah,
will
yeah.
always be
This is
1.
basically it's yeah, correct. So the thing is you can take a to be 1, but there is no point to study logarithm function when base is 1. Okay, it's basically it's a constant function. Okay, what you can study, it's everything is clear about a constant function, right? So that's why he's excluding that case that a is equals to 1, because there is no point to study logarithm base 1 because you have only a constant function.
Yes, correct, sir. I understood. Okay. Thank you very much, sir. Thanks for your time. It's already 10:30.
Yeah, okay, fine.
Sir, one
Okay.
more
Thank you.
question was there.
Yeah, please.
Activity 5.5, sir. Question 5 and 6. So actually, how can we check? Here, hint is given that check from the given options. Sir, can you see the questions?
Yeah, I can see the questions.
Yeah, sir. Then if
Just give me a
how
minute.
can we solve this?
Yes, just a minute. This is the question, right?
Yes, sir. Question number 5 of activity. Question 5.5.
Yeah, so more or less you have to use calculator. Okay, apart from that you can't.
No, sir, I can use calculator, but then also how can
You take log, right?
No, sir, it's the
sir,
No,
polynomial thing,
sir,
sir.
it's a
It's
polynomial.
from week 5, sir. So,
Week 5.
yeah. I mean, he can take it right now, but yeah.
Question number 5. Okay, so there is no log here, right?
no, sir.
Yes,
Okay,
sir.
sorry. It's my minute. Yeah, so again, like if there is no log, then you have to put it for
So
this
we have to
value of,
check for all options.
All
yeah.
options,
No,
3,000, 2,000, everything, all the 4 options you have to check,
you
and
have to check
whatever
and
the
you
answer
have to
is
do it.
coming.
Basically you have to use calculator. Otherwise, without using calculator, so first you have to put t equal to 360. See what
And
you are
same
getting.
for question 6 also, sir.
Then question. So this
6
is
is
question.
also like that here only. Okay, sir. I understood.
Yeah, 6 probably you have to do in similar kind of logic. Okay.
And sir, in lecture 5.8,
Hmm.
determination of domain,
Hmm.
sir told that for defining the domain,
Hmm.
I'm not able to clear.
No, the domain means domain of what? Domain of composite function, right?
Domain of composite function,
Hmm.
sir.
Hmm.
Actually,
Yeah.
I have to dictate a long. Can you see at? Can you see this that lecture at 11 minute 20 seconds? Sir?
11 minute.
20 seconds.
Okay, just a minute. (11 minutes 20 seconds).
5.8 lecture 5.8, sir.
What is your doubt? Okay, so let me
Actually,
see.
my doubt is if for defining the domain of f for g of x,
Hmm.
first we have to see that so rule 1 is that x should not be in domain of g, function g.
No, X should be in the domain. You are trying to find the domain of F compose G, right?
Yes, sir.
Then for that you need to find the values for which X is in the domain of G, right?
Yes, sir.
So then
So I'm not able to.
can you tell me the time which
11:20, sir. Sir told there that in
just a
rule
minute.
2. Yes, sir.
So basically you are talking about that example, right?
Yes, sir. There taken the example of a function fx is equal to 2 upon x minus 1 and gx is equal to 3 by x.
So what is F?
Fx is 2 upon x minus 1
X minus 1.
and
Correct.
gx is 3 upon x.
3 upon
X.
X, right? So
Yes,
you
sir.
want to find the domain of
Domain f
domain of
OG. Yes, sir.
OG, right?
Yes, sir.
So try to understand. So if if G is not defined, is not defined at
So, sir, x should not be equal to 0.
just a minute, just a minute, let me complete. If it is G is not defined at x equal to a, right? Then
Yes, sir.
F compose G can't be defined at x equal to a, right? Because for that, what you need to write? G of a, right?
Yes, sir.
And
Yes,
this
sir.
is not defined,
Yes, sir.
right? So then if A is not in the domain of G, right?
Yes, sir.
If A is not in the domain of G, then certainly it can't be in the domain of
Yes, sir.
F compose G, correct?
Right, sir.
So the next thing is if G of A, okay, let me take some another thing. If G of B is not in the domain of F, sorry, not in the domain of F.
Yes, sir.
So that means B can't be in the domain of F compose G, right?
Yes, sir.
Because if G of B is not in the domain of F, then if I compose this P, then what is this? F of G of B, right?
Yes, sir.
But G of B is not in the domain of F. That means this expression has no meaning, right?
Yes, sir.
So I have to find all such point A, okay, which is not in the domain of G, right? They are not
Yes,
in the
sir.
domain of F comma G, and also I have to find all such B for which G of B is not in the domain of
Domain of
F. What is domain of F?
domain of F is all real numbers. X is not equal to 1.
1.
Yes, sir.
And what is the domain of G?
X should not be equal to 0.
So from here, I can say that 0 is not in the domain of
Yes, sir.
F compose G, right?
Yeah, right, sir.
Because G is not in the domain of G, right?
Yes, sir.
Next, I need to find what are the values for which G of B is not in the domain of F, right?
Okay. Yeah, sir.
Yeah. So basically, not in the domain of F means what? G of B is precisely 1 because 1 is the only value which is not in the domain of F, right?
Yes, sir.
So basically, I need to find the values for which G of B is 1, and I have to exclude all those values, right? Because if G of B is 1, that means G of B is not in the domain of F. That means B can't be in the domain of F compose G, right?
So we have to find all the B for which G B is 1.
1, yeah.
Yeah. So, sir, that should be X is not should not be equal to 3. That is 1.
If G of B is 1, where is G?
Yeah, B will be 3.
Yeah, certainly B will be 3. Yeah, correct. If G of B is 1, that means 3 by B is 1. That means B is 3. So that means B equal to 3
And
can't be in the domain of F comma G. And from the initial argument, we got 0 can't be in the domain of F comma G, and from the second argument we got B equal to 3 can't be in the domain of G. That means the 0, only 0 and 3 can't be in the domain of F compose
yes,
G. That means the domain of F compose G is nothing but R minus 0 comma
minus 0 and 3. Sir, that's what I got from my perception. But in that lecture, sir told that X is not equal to 1. This should also be eliminated from the domain of FOG. That's why I have doubt, and I wanted
Okay,
to
so
show you that.
no, actually, that is actually, let me see what is the definitions are give. The domain of the composite X is in the domain of G, and G of X is in the domain of F, right? Whether he is considering the following values must be excluded from.
Sir also written the same thing, sir, but he told verbally, but he has not written.
Probably he made it's a mistake, most likely. He computed what he computed. He computed this, right?
Yes, sir.
Yeah. Then
Computed this.
mostly it's a slip of tongue, I guess.
But this is for a, more than 30 seconds, sir. This was not a single point of mistake.
Okay, then I will check, because see, the thing is the way sir gave the definition. Okay, then it should be the answer. Okay, if again he is also excluding
Yes,
all
sir.
the points which are
On the point
not
of
in
this. Yes, sir. This only.
not in the domain of f of x. Okay,
Yeah.
in that case, probably you will get one more element, that is r minus
But is
0,
that correct, sir?
0, 1, 3.
But is that correct?
Sorry?
From the definition, it should not be.
No, whatever definition, as far as I remember, whatever definition sir gave, this should be the correct answer.
Yes, sir.
But again, if you add one more condition, that if you add one more condition, if B is not in the domain of F, that means
If you watch for 30 seconds, then it will be very clear. I'm telling the exact point of time at 11 minutes 20 seconds.
11 minutes 20 seconds.
20 seconds, yes, sir.
Okay. Just a minute. 20 seconds.
There is no sound.
Yeah, just a minute. Actually, whatever he said,
That is finding something.
I checked, but I am checking some previous example as well. Basically, he explained only one example, right? In that lecture.
Yes, sir. One example.
Yeah. So certainly, what he's doing, okay. So he's also excluding all the numbers which are also not in the domain of F.
FX.
Which are not in the domain of F of
But
X.
he has not written that thing, sir.
Yeah, that certainly he has not written. Yeah, you are correct. Yeah.
So was that correct or not?
No. It's certainly, you can't say that it's not. It's, as I said, it's completely depend on how you are defining it. Okay, but okay, it seems. So again, like so, the thing is, if you see, he has written these are the things that must be excluded. Okay, so probably, yeah. So I'll suggest you try to go with the example thing, right? You try to exclude all the points which are not in the domain of G. Okay, you try to exclude all the points which are not in the domain of F, and as well as you try to exclude all the point GB which are.
But sir, it is contrary to what he told in the lecture.
No, not.
In all the lecture, he
Just
given
listen
just
to
two
me.
rules. Yes, sir.
Just listen to me. Okay, so the thing is, he said these are the thing must be excluded. Okay, he never said that these are the only thing that must be excluded. Okay, so there is a difference. Okay, I agree to you that he never said that this is this should be excluded. That are one should be excluded. Probably, yeah, in some sense, you are correct. Okay. But again, like one thing he also said, these are the things that must be excluded. Okay. So again, like this is a issue. Okay. Maybe I'll talk with other instructor. Okay. Maybe I'll try to fix this.
Right, sir.
Because yes, certainly whatever you are saying, there is some confusion because he never mentioned probably. Again, I'll go through the lecture properly because I just vaguely went through the lecture but what I saw, like he never mentioned that you remove all the points which are not in the domain of. Okay,
Yes,
but
sir.
while solving the question, actually he's taking this out. Okay,
Yeah,
so
yes, sir.
again, like if you take this out, then certainly you will get a different answer. As you can see, you will get this 0, 1,
Yes.
3. But again, if you are not going to take it, then most you will get this answer. Okay. Yeah, certainly this is the issue. Yeah, Prashant, this is the issue. Probably I'll talk with the other instructor and let's see if we can edit or we can do something with that video.
Okay, thank you, sir.
Yeah, yeah. Okay, then probably I'll stop the session now. Okay.
Yes, sir.
Yeah.
Thank you very much, sir.
Thank you.
Yeah,
Thank you.
thanks.
Thank you so much, sir.
Yeah, thank you.
Thank you, sir.
Yes.
Good night, sir.
Yeah, good night. Good night to all.
Sir.
Good
Good
night,
night,
sir.
sir.